Imagine a robot that can gently pick up a bag of chips without crushing it, or carefully rearrange items in a cluttered box just like you would. This isn't science fiction anymore. Amazon's new robot, Vulcan, is designed to do just that, bringing a sense of touch to the complex world of warehouse logistics and potentially changing how we think about automation and work. Amazon warehouses are incredibly complex environments. They store hundreds of millions of unique items, from tiny electronics to bulky furniture. These items are often packed tightly into bins on mobile shelves, creating a chaotic, cluttered space. For humans, navigating this clutter, identifying the right item, and carefully extracting it is second nature. We use our eyes, our hands, and our brains together, constantly adjusting our grip and movement based on feel. This seemingly simple task is incredibly difficult for traditional robots. Robots typically rely on precise programming and vision systems. They struggle with variability, clutter, and the need for delicate manipulation based on physical contact. Amazon's Vulcan robot is designed to overcome these challenges. Unveiled in May 2025, it's Amazon's first robotic system explicitly equipped with a form of sense of touch. This isn't human level feeling, but a sophisticated use of force feedback sensors. These sensors allow Vulcan to detect contact with objects and the surrounding environment. It can measure the pressure it applies, enabling it to adjust its grip strength in real time. This is crucial for handling the vast diversity of items in an Amazon warehouse without damaging them. Vulcan's capabilities stem from a combination of hardware and software. Its end-of-arm tooling is versatile, featuring tools like spatula-like paddles and suction cups. These tools are designed to interact effectively with the fabric bins and the items inside. The tactile sensors work in conjunction with these tools. When Vulcan reaches into a bin, it can feel resistance or contact. This feedback helps it navigate the cluttered space, push items aside, and find the target object. Once the item is located, Vulcan uses its sensors to determine how much force is needed to grasp or manipulate it. It won't crush a delicate item like a bag of chips, but can apply enough pressure to secure a heavier object. This tactile feedback is key to its dexterity. Vulcan isn't just programmed, it learns. It utilizes advanced AI algorithms trained on physical data gathered from real-world interactions in the warehouse. This is a form of physical AI. Instead of relying solely on simulations, Vulcan learns by doing. It experiences failures, like dropping an item or getting stuck, and uses that data to improve its performance over time. This iterative learning process allows it to adapt to the unpredictable nature of cluttered bins. This learning is also applied to optimizing the stowing process. Vulcan can analyze the properties of multiple items and the available space in bins across several shelves. It uses this information to plan the most efficient way to pack items, maximizing density like a skilled human stower. Vulcan is designed for high-volume operations. It can operate at speeds comparable to human workers handling around 300 items per hour. Furthermore, it can work for extended periods, up to 20 hours a day, significantly increasing throughput. Its ability to work with existing storage pods is a major advantage. Unlike some previous automation systems that required entirely new infrastructure, Vulcan integrates into Amazon's current warehouse setup, making deployment more cost-effective and scalable. By optimizing storage layouts based on real-time data, Vulcan helps ensure that items are packed efficiently. This high-density storage is particularly important in urban areas where warehouse space is limited and expensive. The introduction of robots like Vulcan naturally raises questions about the future of human jobs in warehouses. Amazon emphasizes a model of co-working or human-robot collaboration. According to Amazon, Vulcan is intended to handle tasks that are ergonomically challenging or repetitive for humans. For example, it can reach items on high shelves, reducing the need for ladders, or access items on low shelves, minimizing bending. This could potentially reduce strain and improve safety for human workers. In this collaborative model, humans would focus on more complex tasks that still require human judgment, problem solving, or interaction. Some employees might transition to new roles involving monitoring, maintaining, or operating the robotic systems. However, critics argue that while some jobs may be transformed, the overall number of human positions could decrease. Automation, by its nature, aims to perform tasks previously done by humans, potentially leading to job displacement in the long run. Analysts have voiced concerns about the potential threat automation poses to warehouse jobs, despite Amazon's claims of upskilling opportunities. The scale of Amazon's operations means that even a small percentage of tasks automated can impact a significant number of workers. The transition to new technical roles requires training and adaptation, which may not be accessible or suitable for all employees. This creates a societal challenge in ensuring a just transition for the workforce as automation advances. Safety is a paramount concern when robots operate alongside humans. While earlier discussions sometimes hinted at direct human-robot interaction zones, Vulcan currently operates in segregated areas within the warehouse. This segregation minimizes the risk of collisions or injuries to human workers. Robots handle tasks within their designated zones, and items are transferred between robotic and human areas as needed. This approach prioritizes safety by creating clear boundaries. As robotic capabilities advance, the nature of human-robot interaction in shared spaces will continue to evolve. For now, keeping Vulcan in segregated areas is a key safety measure during its initial deployment and scaling. Vulcan is not just a lab prototype. It's being deployed in real-world operations. It has been piloted in fulfillment centers in Spokane, USA, and Hamburg, Germany. These pilots allow Amazon to gather performance data and refine the system in operational settings. The plan is for global expansion, integrating Vulcan into more of Amazon's vast network of warehouses. Its compatibility with existing infrastructure makes this scaling process more feasible and less disruptive compared to systems requiring significant facility overhauls. The success of these initial deployments will determine the pace and scale of future rollouts. As Vulcan handles more items and operates in more locations, its impact on efficiency and the workforce will become clearer. Beyond the job displacement debate, Vulcan has faced other criticisms. The very claim of having a sense of touch has been debated. Critics argue that while Vulcan uses tactile feedback, it's not comparable to the complex, nuanced sense of touch humans possess. They suggest that Amazon's marketing might overstate the robot's capabilities, comparing its tactile feedback to more simplistic object handling systems. While Vulcan's use of force sensors for manipulation is advanced for warehouse tasks, it's important to understand the technical definition of its touch. This debate highlights the need for clear communication about robotic capabilities. As robots become more sophisticated, accurately describing their senses and abilities is crucial for public understanding and managing expectations. Vulcan is a cutting-edge development, but it exists within a broader landscape of robotics research and deployment. Similar technologies are being developed and used elsewhere, reflecting global trends in automation. Industrial robots have long used force control for manipulation, seen in systems from companies like Boston Dynamics or Apptronik, though often focused on different tasks like mobility or general purpose handling. Research labs are also developing robots with advanced haptic feedback and soft robotics for delicate tasks. In warehouse automation specifically, other robots like Agility Robotics Digit or Amazon's own earlier Sparrow robot use vision and suction for picking. However, Vulcan's key differentiator is its ability to effectively navigate and manipulate items within dense, cluttered bins using tactile feedback, a task many other systems struggle with. The ability to handle cluttered bins is a significant scientific and engineering challenge. Humans do this by instinctively using touch to feel around, push things aside, and adjust their grip. Replicating this in a robot requires sophisticated sensing and planning. Vulcan's system uses AI to plan its movements in these contact-rich environments. It anticipates contact and reacts to it in real time. This is a departure from traditional robots that operate best in highly structured, predictable settings. The system also learns bin etiquette, understanding how items are packed and how best to extract them without disturbing others or getting stuck. This involves building foundation models of items, learning properties like how squishy or fragile they are, and how they interact with other items. For a system operating at Amazon's scale, reliability is paramount. Even rare errors, occurring perhaps once in a million picks, can happen many times a day across hundreds of warehouses. Vulcan needs to perform consistently and accurately. Amazon is heavily focused on improving Vulcan's reliability. This involves refining its AI, improving its hardware, and developing techniques like visual servoing, where the robot watches its own movements and adjusts them to prevent errors before they occur. Despite advancements, there will always be unusual situations or items that the robot cannot handle. In these cases, the system is designed to recognize its limitations and hand the task off to a human worker, ensuring the process continues smoothly. Amazon views the challenges of warehouse manipulation as a proving ground for broader robotic capabilities. The science developed to handle high contact and high clutter in bins could be applicable to many other areas. The ability for robots to reliably interact with unstructured, messy environments is a key goal in robotics research. If robots can master the chaos of an Amazon bin, the underlying technology could potentially be used in manufacturing, healthcare, or even domestic settings in the future. Vulcan represents a significant step in this direction. It pushes the boundaries of physical AI and tactile manipulation in a large-scale, real-world application. While its immediate impact is on logistics, the lessons learned could contribute to the development of more versatile and capable robots for a wide range of public and industrial purposes. Amazon's Vulcan robot is a notable milestone in the field of physical AI and tactile robotics. By integrating force sensing and advanced AI, it brings a new level of dexterity to warehouse automation, promising increased efficiency and potentially improved ergonomics for human workers. However, its introduction also highlights critical public discussions about the future of work, the nature of human-robot collaboration, and the societal impact of widespread automation. Understanding the capabilities and limitations of systems like Vulcan is essential as we navigate this evolving technological landscape. Stay informed about these developments and their potential impact on jobs, safety, and the economy. Engage in discussions about how automation can be implemented responsibly to benefit society broadly. Explore resources from robotics experts and labor analysts to form your own perspective on the future of work in the age of intelligent robots.